It's a good thing that you told now, because not much has been recorded, not much has been discussed so far. Most of the things we have discussed so far were already discussed in the last lecture. So let me just quickly one time and tell what has been what we are teaching. So we are teaching combinations because we have already discussed about permutations in the last lecture. Now we are discussing combinations, and in combinations what we are saying that if you have a set A, and if you, let's assume that you want to make subsets of this set. If this is the set, then you want to make subsets of this set. So S is a subset of set A, and let's assume you want to make subsets which are of size 3. So you are interested in only in subsets of size 3. Then we are saying that this problem is different from the permutation problem, because in permutation problem what we were doing, first we were picking R elements, first we were choosing R elements, then we were arranging those R elements. Okay, but here what is happening, first we will pick R elements. Let's assume here we are picking only 3 elements because we are interested in subsets of size 3. So here we are picking 3 elements, and then once we pick 3 elements, then you can see ordering does not matter, because with 3 elements, okay, let's assume you have picked 1 comma 2 comma 3. With these 3 elements, there is only one possible set you can make. So this is the only possibility, because set is a ordered collection. So in set, order does not matter. So this problem is different from the permutation problem. In this problem we do not have to arrange. In this problem we only have to select. So the only work we have here is selecting 3 elements from this set. We are not going to arrange it, or you can say we are not going to permute this thing. That what we are saying, basically we are saying, basically what I'm saying is permutation. You can think of permutation as, or permutation is similar to arrangements, or arrangements is similar to ordering. So you can see in all these things, order matters. Permutation, arrangement, or ordering, in all these things order matters. And combination, what do we have, what do we mean by combination? Combination means selection. Okay, selection. Or here you can see, order does not matter. The only thing matters is what are the elements that you have picked. Now we will see how many combinations are possible. Now our task is to see how many combinations are possible. So let's see this, how many combinations are possible. Remember, in permutation problem what were we doing? In permutation problem what were we doing? So we had some n elements. You can see in permutation problem we had some n elements, and we our what we were doing, we were picking r elements. First we were picking r elements, and then we were arranging them. So this is our first, it we were doing this, picking r elements from this set of n elements, and then we were arranging them, and then we were arranging those r elements. So you can see the final answer was npr. We have already discussed this in previous lecture, because to fill this position we have n choices, to fill this position we have n minus 1 choices, and so on. To fill this position we have n minus r plus 1 n minus r plus 1 choices. So you see, this is what we saw in last lecture. So these are the number of, this npr is the number of arrangements possible with r elements out of n elements. So now here one thing that you can see, what is that thing? That actually this npr basically is a sequence of two tasks. This npr is basically sequence of two tasks. The first task is, first you pick r elements. First you pick r elements. Okay, so first you pick r elements. So let's pick r elements. let's assume that this is some formula that picks r elements. Okay, now after that, after picking r elements, we have to also arrange those r elements, right? We have to arrange those r elements, and we already know how many ways are there to arrange r elements, that is r factorial. Did you understand? So let me just quickly let me give you overview. We have already seen in last lecture that if you have n elements, and from those n elements, if you want to arrange r elements, then this is the formula. This we have already discussed. Okay, now I am saying that this task, which task? This task, that arranging r elements from n elements, arranging r elements from n elements, this task can be divided into a sequence of two tasks. What is that sequence? The first is, first you pick r elements, first you pick r elements, then you arrange those r elements. So okay, first you pick r elements and you arrange those r elements. So you can see here, we are multiplying. Why? Because you can see there is a and there. Okay, so we are going to use the product rule. So we do not know how many ways are there to do this task. What is this task? Yes, yes, yes. We are going there. We are going there. NCR. We are going there. So I am saying that we let's assume that so far we do not know how many ways are there to do this task, and this task is picking our elements. So let's assume that there is some formula, and this formula is somehow picking our elements. So this formula is actually giving us number of ways to pick our elements. So once this task is done, now let's go to this task. This task is to arrange those r elements. Now you already know that how many ways are there to arrange r elements. If you have r elements, then you can arrange them in r factorial ways. So now actually we are interested in this, we are interested in this. Now actually this is you can say this is our selection of r elements, and this is what we are interested in, because in combination is nothing but selection. So we are interested in how many selections are possible of r elements from a set of n elements. If you have a set of n elements, then how many r element selection are possible. So actually this you can see this is the selection of r elements. So what will be this formula? From here you can find, okay, let's call this ncr, let's call this ncr. So this ncr will become npr divided by n factorial. So this is our final formula. We already know what is npr. Okay, and npr divided by r factorial, this will be the number of selections possible of r objects from this set of n objects. So this is our combination formula. So this is what we are looking at here. So this is what we are looking at here, combinations. So we are only interested, whenever you are interested only in the selection, not in the arrangement. Whenever for you arrangement does not matter, at that time you should think of combination. So whenever you have to select a few things from a set, if you have a set and you want to select few things, then you should think of combinations. So if you have a set of n objects, let's assume you want to select only r objects. So this has n objects, but you want to select only r objects, then how many ways you can select r objects? That is ncr, and that is equal to npr divided by r factorial. So this is what we have seen in so far. Okay, now let's solve this question. Let me first quickly solve this question. How many different committees of 3 students can be formed from a group of 4 students? So in a class, let's assume you have these 4 students. So these are the these are the 4 students. Now you want to make a committee of 3 students. You already know that in committee, like if there is a committee, if there is a group, then in friends group, in friend circle, the order does not matter. So you want to make a committee of 3 students. So how many ways you can make a committee? So we already know that how many ways to make a committee is similar to asking how many ways are there to select 3 students from these 4 students. So we just want to select 3 students out of these four students, so how many ways we can select them? So we can select them in 4c3 ways. And what will be 4c3? We have already seen what is the formula for this NCR. So this will be 4 factorial divided by 3 factorial into 1 factorial. What is 4 factorial? 4 factorial is nothing but 4 multiplied by 3 factorial, right? Now you can just cut and the final answer will be 4. So you can see how many ways are there to form a committee of 3 students from the set of 4 students. That will be answer will be 4. So so hopefully this combination is clear. So basically this is the actually derivation of this formula. This whatever we did here, this is the derivation of the formula of NCR. We wanted to derive the formula for NCR, and now we have derived that NCR is equal to NPR divided by R factorial. We already have derived the formula for NPR in the last lecture. How did we derive it? That same method. First position n, second position n minus 1, and so on, and last position n minus R plus 1. So all these things we have derived. Okay, I do not want you to by heart anything. So that's why I wanted to derive it. But you might already know what is NCR. Okay, you might already know that selecting R students from a set of n students, that can be done in NCR ways. All these things you might already know, but I wanted to derive it so that you know that how we can derive these formulas. You just uh, only by hearting this formula is not enough. So this is the solution for the last question. Now let's take one more question for okay, so this is just the theory. So if you have a set of n element, this is just the theory that you if you have a set of n elements, and if you want to select R elements, you are just interested in selection of R elements, then that can be done in NCR ways. So this is just the theory of that. Now let's see. Okay, again, this is the formula that we have already derived. This is the formula that we have already derived, that if you have a set of n elements and if you want to select R elements, then that you can do in NCR ways. So of course this R goes from 0 to n, because if you have n elements, then at max you can select n elements, and minimum you can select 0 elements. So selecting 0 elements means you are not selecting anyone, you are just rejecting everyone. So this finally how many ways are there to select R elements is this. So all this theory we have already seen. Now let's solve this question. So try to solve this question. You have to decide whether it is a permutation required, whether arrangement required, or whether only selection required. All these things you have to decide. Solve this question. Right. Correct. They both mean the same. Yes. Right. Right. Gayatri, Santosh, are you trying? Okay. So let's see this. How many? He is saying that in the cards game you have, so you have these many cards, 52 cards we have, and basically let's assume that there are four people and we are just giving them five cards. So we are giving him five cards, then we are giving him five cards. So you know how cards are played. So he is saying that how many ways are, let's assume that in the beginning you want to give him five cards. So like how many ways you can give him five cards, or you can say how many ways he can receive five cards. So that you remember that when you are giving five cards to him, then order does not matter. Like you are just giving five cards to him. Okay, if he gets a two, a three, a four, a five, a six. So if he gets these cards, and let's assume all the cards are of you can say this same suit, then in whichever order you give him, it doesn't matter to him. So how many ways are there to select five cards out of 52 cards? That is this. So this is the number of ways to select five cards out of 52 cards. Now let's see the second question. He is saying how many ways are there to select 47 cards. So this is the number of ways to select 47 cards. From 52 you are selecting 42. Now why actually Sanjeev is saying that both are same. Why is it the case? So this is the case because if I give you a set, let's assume if I give you a set A B C D, and if I tell you to select three elements, if I tell you to select three elements, then saying that select three elements. So actually what I am saying that select three elements, saying that select three elements is same as saying reject one element. Am I right, or am I right? So basically I'm saying that you need to select three elements is similar to saying reject one element. Reject one element. So you can see how many ways we can do this selection. This we can do in 4C3 ways. Now if you are selecting three elements, automatically you are basically rejecting one element. So for every way, okay, let's assume here you selected A B C, then automatically you will get one way here, and that will be D. Basically if you select A B C, then you are basically rejecting D. Now number of ways to select three cards is similar to number of ways to reject one card. So that's why okay, selecting three cards is 4C3, rejecting one card, so rejecting one card, that is 4C1. You can choose any one card and then you can reject it. So these are same because selecting three cards is similar to rejecting one card. So actually you will see these are equal. So that's why actually it is happening, because there is the formula ncr is equal to nc n minus r, and we have already seen the intuitive proof of that. So the proof is that if you are selecting r elements from a set of n elements, if you are selecting r elements from a set of n elements, then that is similar to saying that you are rejecting n minus r elements from the set of n elements. Because if you are selecting r elements, basically you are rejecting all the remaining elements. So that's why actually this formula we have in combinatorics. Okay. That's why actually Sanjeev is saying that they are both same. Now let's move on. So this is the solution. You can refer to this solution. Now note that so this is the formula that we have already discussed, ncr. So remember one thing. We can write ncr in this way also. Similarly we can also write it like this, c n comma r. So this is same ncr. We can also write it like this, n r. So we can also write it like this. So this is again, this is also interpretation. For example, if I write like this 4 2, then that means 4c2. Remember, these are just the different ways of writing. So what is this? This is ncr is equal to ncn minus r, and we have already seen this, how why actually this is true, and the proof. So the proof is simple. Selecting r means rejecting n minus r. Now, so try to solve this question. Try it. Right. So you can see, he is saying that if you have an length bit string, how many bit string contain exactly r ones? the the thing is, in a bit string, you only, either you have 0 or you have 1. You can only, you only have 2 bits, right? So he is saying exactly r ones. What does it mean? Exactly r means ones means, you can say n minus r zeros. Okay. So these are the, let's assume we want to make bit strings of length n. Then you know that the order among these order among these ones does not matter. For example, 110. Now if I reorder the first two ones, then again I will get 110. So you can see the order here does not matter. So what we can do, we can make like this. From these n positions, you can select r positions. From these n positions, you can select r positions. And once you have selected r positions, in those r positions you can put ones. You know that once you have selected, let's assume you have selected this and this position, then there is only one way to put ones. Why? Because if you put one here, if you put one here, then there is only this way, because you cannot just you cannot just interchange them, because order does not matter among zeros, order does not matter among ones. So what you can do, from n positions you can select r positions, and then in those r positions you can just directly put ones, and in the remaining positions, who will come, 0 will come. So you can see, once we select r positions from these n positions, okay, after that, we do not have to do anything, because once we have selected r positions, we can put ones there, and in the remaining positions we can put zeros. So this is the number of ways we can make n length strings with exactly r ones. So this is again an example of combination. Okay. So whenever order does not matter, remember, whenever order does not matter, then just think of combinations, and whenever order matters, then think of permutations. Let's solve this one more question before going further. Solve this question. Okay, Sanjeev is multiplying and Gayatri is adding them. Let's see what happens. He's saying that suppose that there are 9 faculty members in mathematics department, 11 in computer science department. How many ways are there to select a committee to develop a discrete mathematics course at school if the committee is to consist 3 faculty from the mathematics department and 4 faculty from computer science department? So you see, because of this, and actually there will be multiplication because of this, and because let's see this. Okay, you got it, huh? So do we need to solve it? Let me just quickly solve it, huh? Because I think everyone has already gotten the answer. Let me just quickly solve it. So what he's saying, there are 2 departments and here there are 9 faculty, here there are 11 faculty. Now he's saying how many ways are there to form a committee. You want to form a committee, okay, you want to form a committee. In that committee, 3 faculty members must come from here, and 4 faculty members must come from here. So 4 faculty members, it is saying, he is saying that 3 faculty members come from mathematics department and 4 faculty members come from computer science department. Okay, so how many ways you can form committee? The number of ways to form committee, basically you have divided your task. Okay, to form a committee you have divided your task. The first task is to select three elements from here, and the second task is to select 4 elements from here. Selecting 3 elements from here can be done in these many ways, and selecting 4 elements from here can be done in these many ways. And remember that you need to complete both the task to complete the formation of a committee. So you have to complete this task also and this task also, and because of that, by product rule we will get this is the answer. Okay, so you have already solved it. Let's see. So this is the answer, you can refer. Now after that, let's move on to our binomial theorem. So this is the next topic. So you must already know what is a binomial theorem. I just want to quickly go over it because this is a easy thing. And let's see. So binomial theorem is saying that if you have this x plus y power n, then what is the expansion of it? For example, you already know that x plus y whole square. If I want to make x plus y whole square, then what is this? This is nothing but x plus y multiplied by x plus y, right? Now if I want to multiply these two, okay, if I multiply this with this, then what I can do, you know that if I multiply this and this, then basically what I can do, I can take one element from here and one element from here, then I can multiply. For example, I can take x from here, then I can multiply them, plus, or, so this means or. Okay, remember actually what we are doing, we are selecting, we can take one element from here, we can take one element from here. Okay, so we can multiply them. So if we pick x from here and if we pick x from here, then we will get x square. Or what we can do, remember, whenever we in combinators, I have already mentioned the sum rule. Whenever we feel like or, okay, so what we can do, or we can pick x from here and y from here. Or what we can do, we can pick y from here, x from here. Or what we can do, we can pick y from here and y from here. So you already know this formula, x square plus 2xy plus y square, and this is how it is, and this is how we get it. Now the binomial theorem is basically what will happen if we have a power n. So for binomial, now we need to see what is a binomial theorem. So let me first quickly give you the uh, let's go through the proof of binomial theorem. So if you have x plus y power n, then I can write it like this: x plus y multiplied by x plus y and so on multiplied by x plus y. These are n times, right? These are n times. So we have n times x plus y, x plus y, x plus y. Okay, right? I can write it like this. Now 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 I want to multiply all of them. So if I multiply all of them, what will happen? What will happen? How how I can form a term here? So I can pick either x or y from here. I can pick either x or y from here and I can put it here. So let's assume I pick x from here and I put it here. I can pick either x or y from here, then I put it here. Let's assume again I pick x. So is and so on. So from each from you know how to make this term. So this is a term, and so on. You can make many terms. So from the last, let's assume we picked y. Okay, so actually from every this xy pair, x plus y pair, we can pick one element. This is how we can form a term. Okay, because we multiply them, and this is how we can form a term. So how many different terms will come? You here actually you picked x. Now in the next term, maybe you can pick y. Okay, so you can see maybe you can pick x and so on. So this is how you will get your terms. Okay, now let's try to find out one thing also, that if I have this term is same as if I have this term, right? Because xy is same as y into x, and this is same as x into y into x. So what matters to us? The only thing matters to us is how many number of x we have and how many number of y's we have. Okay, so our target is to compute. Let's compute how many number of x we have. Let's compute how many number of x we have and how many number of y's we have in a term. So you see, this is our formula, and let's assume that x we got x power r. Okay, let's assume that we got r x's. So how many y's will be there? Automatically, how many y's will be there? N minus r. Because we have basically if we have x r's, then we will have n minus r y's, right? Now let's see how many these terms are possible. Let's see how many these terms are possible. So these type of terms, how are they possible? They are possible if we choose uh, if we choose r pairs. So we have these kind of x plus y and these kind of pairs we have. So if we choose r pair out of these so how many pairs we have? N pairs we have. If we choose r pairs from these n pairs, okay, then what we can do, from those we can get x, and from the remaining we get y. So you can see how many this kind of terms will be possible. So this kind of terms will be possible is NCR. So NCR is the number of terms, okay, of this form. So finally what we can uh, remember that this r goes from where to where. R can minimum be 0. Minimum r can be 0. When r becomes 0, what does that mean? It means that you have not picked x, because r is 0. So if x power 0 means you have not picked any x. So from each of these pair you have only picked y, right? Or at max what you can do, r can go to n. So when r becomes n, what does it mean? It means that you have picked x from everywhere. So in this case, y will become 0, because if you put r equal to n, then it will become x power n, and it will become y power 0. So r can go from 0 to n. So r can take any value. R can take 0 value, r can take 1 value, r can take and so on, and this value n. So you see, these all are the possibility for our terms. Okay, now so when r takes 0, then we will get what we will get when r takes 0. So just put it here. So we will get x power 0 y power n. This is what we will get when r takes 0. So how many these terms are possible? How many these terms are possible? You know that how many these terms are possible. NCR and r is 0. So these many terms are possible. Plus, now let's see when r takes value 1. So when r takes value 1, then x power 1 and y power n minus 1. Again, how many these terms are possible? We already know how many these terms are possible is NC1, because R is equal to 1. So this way we can go. Okay, this way we can go, and finally we will have when R will become n, at that time what will happen? So x power n, y power 0. And again, how many these terms are possible? We already know how many these terms are possible is ncr r. You can put the value of r equal to n, so this will be ncn. So this is final expression for x plus y power n. Okay, so don't worry about it. Even if you did not get the whole proof, you can revisit this proof. I just wanted to give you some intuition behind this formula. We could have we already know this formula, this binomial formula. We have already studied this binomial formula, and you might already know it. But I wanted to give you like how you can prove it, how you can prove it. So let me just quickly go over this the review of this proof. The proof is simple. You can write this x plus y power n in the form of x plus y multiplied by x plus y multiplied by and so on. So these kind of n pairs will be there. Okay, these kind of n pairs, these kind of n pairs will be there. Now when you multiply them, then how do we multiply them? We select either x or y from the first pair, we select either x or y from the second pair, and so on and so on. So from each pair we can either select x or we can select y. Okay, so whatever we do, so let's assume we got x number, sorry, r number of x's, and we got automatically we will get n minus r number of y's, because if you select x from r pairs, then that means that you have selected y from remaining pairs, right? So automatically it will mean that you will select y from the remaining pairs. Now we are interested in how many pairs are possible, how many pairs are possible such that sorry, how many ways are possible such that uh, r x are selected, okay, and n minus r y's are selected. So we are interested in those number of ways. So we have seen this is the number of ways that are possible to select r x and n minus r y. So that is this ncr. Okay, so why is this ncr coming? Because you have n pairs, and from those n pairs you can choose r pairs, and from those r pairs you can take x. Okay, automatically from the remaining pairs this y will come. Okay, so now we saw that this r goes from 0 to n. Why? Because it may be possible that you do not select x at all, so from each pair you might select y. Similarly, when r goes to n, that means that you are selecting x from everywhere, you are not selecting y. So you can see r goes from n to r goes from 0 to n. So when r becomes 0, at that time you will get this kind of terms, this kind of terms. So how many this kind of terms are possible? nc0. Similarly, when r becomes 1, then you will get this kind of terms. So how many this kind of terms are possible? nc1, and so on. So when r becomes n, then you will get this kind of terms. And how many this kind of terms are possible? ncn. So you can just add them, and finally we will get our expansion. So so this is binomial theorem. I just wanted to give you a quick proof, or you a quick idea for proof. So that's why I spent this much time. So but this is our binomial theorem. uh, we can write it like this: nc0 x power, remember one more thing, because ncr is equal to ncn minus r. We already know this, right? ncr is equal to ncn minus r. So what we can do, we can write this nc0 as ncn. Similarly, we can write this nc1 also equal to ncn minus 1. Also we can write this ncn equal to nc0. So that's why actually you can get many expressions, but all these expressions are same. For example, we wrote this expression. In this expression, what we were doing: nc0 x power 0 y power n, and so on. You can see in this expression what he is doing nc0 x power n, nc1 x power n minus 1. So this is also a correct formula. The only thing that he has done is he has used the formula nc NCR is equal to NC n minus r, n minus r. So he has replaced NCR with NC n minus r. This is what he has done. So you can get multiple formula, but all these expansions are equivalent. All these expansions are correct. So this is our binomial theorem. Now in this binomial theorem, you can see we are using this NCR because R goes from 0 to n. So we are using NC0, NC1 and so on, NCn. So that's why actually this NCR is also known as binomial coefficient, because you can see in binomial theorem this NCR is working as a coefficient. This NCR is working as a coefficient of terms. And what are terms? These are terms, this x and y, these are the terms, and this NCR is working as a coefficient. So this NCR is also known as binomial coefficient. So this is our binomial theorem. I have already given you some idea how you can prove it. So we have already proven it, and this is our binomial theorem. So let's take one example. Try to solve it. What is the expansion of x plus y power 4? So you need to write the expansion of this x plus y power 4. You need to write the expansion of it in terms of NCR, right? You do not have to calculate the value of NCR. Just write in terms of NCR. You do not need to write the answer in the chat box. You can just say done whenever you are done, and then you can match your answer. Is this binomial theorem clear? Like, is the idea, like the proof idea, is it clear how you can prove it? Because many times students actually know the expansion of binomial theorem. Mostly everyone knows what is binomial theorem, but many students do not know how they can prove this binomial theorem. So that's why actually I wanted to provide you with this idea of proof. So that's why we have taken 3-4 minutes to just prove this binomial theorem. Done. Okay, so you can check your answer now. So I have written this answer here. You can check. This will be your final answer. So you can check it afterwards. Okay, let's move. Let's solve this question. This question you can try. Yes, Santosh, now try this question. What is the coefficient of x power 12 y power 13 in the expansion of x plus y power 25? You need to find basically the coefficient of this term. Right. So basically he is asking that when you expand it, okay, at that time what will be the coefficient of this term. You already know that when you expand this thing, then what are the terms you get? You get the terms of this form: x power r, y power n minus r. So this is the type of terms that you get. Okay, so he is asking uh, what is the coefficient. By coefficient he means that how many these terms are possible, how many these terms, x power 12, y power 30 13, how many these terms are possible, he is asking. So you can just simply either you can use the binomial theorem. So binomial theorem, you already know that what it does. So there are binomial theorem says that there are NCR ways for x power r, y power n minus r. So we have already seen this. We have already seen this, that this term x power r n minus x power r, y power n minus r. How many these terms are possible? We have already seen that these many terms are possible: x power r, y power n minus r. How many these terms are possible? This many terms are possible. So this is basically the coefficient of x power r, y power n minus r. Now you can just replace value r for 12 and you will get the answer 25c 12. Remember that your answer is also correct because we already know ncr is equal to ncn minus r. So this is also correct. Okay, so this is the question. So it is easy actually. Binomial theorem, we have seen the proof of this. Then we already know the statement of binomial theorem. So what is the expansion of x plus y power, and we already know the expansion of this. But remember that there are many different expansions possible. Why? Because ncr is equal to ncn minus r. So actually because of this identity, different expansions are possible. Like Sanjeev and Santosh gave the answer 25c13, but I gave the answer 25c12 because both are same because of this formula ncr equal to ncn minus r. We have also seen the proof of ncr equal to ncn minus r. We have also seen the proof of that also. Now let's see. Now let's move forward. So this is the answer, you can just easily see now. Now this is a easy thing. This formula. So this formula you can derive basically. Okay, what this is saying. First, let's understand what this is saying. He is saying k from summation of n k such that k from 0 to n is equal to 2 power n. So he is saying that summation of n k where k is 0 to n. So when k is 0, then this means n 0. When k is 1, then that means n 1. And when k is 2, then n2, and so on. And finally the value that k can take maximum is n. So k will go from 0 to n, and the summation of this thing is a 2 power n. So this is what he means by this. Okay, and remember that this nc0, nc1, these are nothing but ncr, because we have already seen how we can write this ncr. We can also write it like this. So we can we prove this, that summation of all these ncr are from 0 to n, this is equal to 2 power n? Can we prove it? We can easily prove it from binomial theorem. You see, we already have seen this binomial theorem, x plus y power n and so on. We already know the expansion of this. Now just put x equal to y equal to 1. So just put x equal to 1, y equal to 1. So you will get this. Okay, and in the expansion if you put x equal to 1, y equal to 1, then what will you get? So you see, in this binomial theorem you can see, yeah, here you can see that if you put x equal to 1, y equal to 1, then what will happen? Then everything will become one. These kind of terms, x power r, y power n minus r, these kind of terms will become 1. So the only thing will be, we will be we will be left with is nc0 plus nc1 plus and so on plus ncn. Okay, so that is equal to 2 power n. So very simple actually, very simple proof. Just put x equal to 1, y equal to 1, automatically you will get what we were discussing. automatically you will get what we were discussing, this, not this, this. Okay, so once you put x equal to 1, y equal to 1, automatically you will get this formula. So this formula also tells us that basically these NCR, addition of summation of this NCR are from 0 to n, that is equal to 2 power n. Okay, now again, you can easily solve this, you can easily solve this. I leave it up to you how you can solve it. You can easily prove it, so you should try to prove it. I am giving a hint. If you want to prove it, then you can then in binomial theorem you can put x equal to 1 and y equal to -1. So try this today, that when you put x equal to 1, y equal to -1 in binomial theorem, then you will get this. Okay, because you can see when you will put x equal to 1, y equal to -1, then on this side you will get 0, right? And on this side you will get this. Okay, so you can try this. Once you put x equal to 1 and y equal to -1, you will be able to prove it. Okay, in the binomial theorems, a simple substitution, a simple substitution. Okay, now let's see. Now, so this is you can take this as a homework. Now let's see what is a generalized permutation and combination. So far we have already been talking about permutation, combination. We have already seen these kind of things, but there we were only considering distinct elements. Okay, we were, for example, if you have this word car. Okay, so how many different arrangements are possible? How many different arrangements are possible? You already know, because these are three words. Sorry, these are three letters, and all are distinct. So if you want to find how many permutations are possible or how many arrangements are possible, then that will be 3 factorial. So this we already know. But you see here, all the elements are distinct. That's why this formula is coming. But what will happen if two elements are same? For example, CCA. Okay, now how many you can make, how many different arrangements you can make? For example, CCA is one arrangement, CAC is one arrangement, ACC is one arrangement. Can you make any more arrangement? Remember, this 3 factorial is nothing but 6. So when all the three elements are distinct, at that time you are getting 6 permutations or 6 arrangements. But what will happen if there is some repetition, like CCA? What will happen if all are not distinct, some are same? Then what will happen? So how many ways are there uh, to arrange this word? So you can see, you can only find 3 ways, because these, if you interchange these two c's, then again you will get this word only, right? So that's why now basically we want to consider this thing, how permutations with repetitions. Permutations with repetition, basically when some elements are identical, when some elements are identical, at that time what will be our approach? Hmm? So for that, let me take let me take one example, and then we will consider the theory. So try to solve this question, try to solve this question, try it. I remember in the last lecture we have already seen, we have already solved this question. 26 PR. How many strings of length R can be formed from the uppercase letters of English alphabet? Repetition allowed or not? See, actually, this question is in itself it is complete question. So in exam, if they ask you this question, then you should yourself you should find out whether repetition is allowed or not. This is a complete question. So you can see in this question he is interested in forming strings of letters uh, so length r, okay, and each of these letters can be some alphabet. So he has only mentioned this thing. So yes, of course repetition is allowed, uh, because you already know that this a b c d, this is also a string of letters, right? So he is interested in how many strings of letters are there. So this is also a string, right? So that's why actually when you are repetition allowed or not, I could have just said yes, repetition is allowed. But the thing is, this question itself is a complete question. Okay, so you can you can find that repetition is allowed or not from the meaning of this question. He is interested in strings. He is interested in strings of length r. For example, if he was interested in strings of length 5, then this is a valid string of length 5, right? So that's why. So yes, repetition is allowed. Now try to solve it. Right, Gayatri, you want to repetition is allowed, remember. Right, because this 26 PR, this will be answer if repetition was not allowed. But you see in this question he is interested in strings of length r. So if he was interested in strings of length 5, then this is a valid string. So that's why. So from the meaning of this question you can find out that yes, repetition is allowed. And if repetition is allowed, then you can put any of the 60 sorry, if you can put any of the 26 letters here, you can put any of the 26 letters here, you can put any of the 26 letters here, and so on. So finally you will get 26 power r, these many permutations you will get. Okay, now basically this is the theory. This is this line is just the theory. Remember, we will also revisit this thing that when this kind of some elements are repeating at that time, how many arrangements are possible, we will revisit this thing. Okay, so let's not consider it here, because in the further slides I have put this thing. Okay, so right now we are considering what will happen, what will right now what we are considering. So we are considering this: if you have an element set, if you have an element set and you want to make a r permutation, remember that repetition is now allowed, because in the previous cases when we were looking at permutations, at that time we did not allow repetition. At that time we got the formula npr. Why we got the formula npr? Because we did not allow repetition. And since we did not allow repetition, so we could put any of these n elements here, we could put any of these elements here. But once we have put some element here, now we cannot repeat it. Hence we have to put we only have n minus 1 ways to put element here. Similarly, we only have n minus 2 ways to do this task, and so on. So that's why we were getting npr. But now what he is saying, Now our question is different. He is saying that you have n element set, okay, but you want to make r permutations where repetition is allowed. You want to make r permutation where repetition is allowed. So what you can do now, you can put any of the n elements here. You can put again whichever element you put here, you can again repeat it. So you can put n elements here, again you can put n elements here, and so on. So finally our answer will be n power r. Okay. Now let's see some. So this is the solution. You can refer to this solution. 26 power r, this will be the number of strings possible. Now let's see combinations with repetition. Okay, combinations with repetition. And to understand this combination with repetition, let's consider this example. So you try to solve it. You try to solve it however you can solve it. Okay, you try to solve it, maybe manually, maybe brute force, however you can solve it. Just try to solve it. Once you solve this problem, then we will see from this question we will see how we can make combinations with repetitions. This question completely describes what this question wants you to find out. Completely complete description is given. You can see everything is given. Just try it however you can do it, maybe brute force or maybe some method. Let's see after that. Yeah, let's see, Santosh. Don't worry about it. So far, we have not seen this concept. I just want you to attempt it, because once you attempt it, you might wrongly attempt it. Okay. So then when I explain, then at that time you will get, okay, this is the this is the incorrect thing that you were doing. So let's see this. What he is saying, he's saying this, that how many ways are there to select four pieces of fruit. Okay, you want to select Remember, you want to select. So he is saying you want to select. So order does not matter, of course. For example, if you are in a if fruit market, in a fruit market, if you go and you take two apple, one orange, one mango, okay, then order does not matter, right? You do not care about whether in your polythene, the first the apple, first the apple you put, then you put mango, then you put apple, then you put orange. So this kind of order does not matter. You are only interested in selection of four pieces of fruits from a bowl containing apple, oranges, pears. So what he is saying that there is a fruit market. In this fruit market, there is a counter where we have apple. There is a counter where we have oranges, and there is a counter where we have pears. Okay. Now he is saying that the order in which the pieces are selected does not matter, right? You just want to select pieces. So you want to select four pieces. Now he is also saying that only the type of fruit and not the individual piece matters. Okay, only the type of fruit matters. For example, let's assume here, if you have two apples, here if you have two apples, and if I tell you to select one apple, then how many ways are there? If there are this line only the type of fruit matters, not the individual piece. So that means that if you have two apples, let's assume if you have two apples, then 2C1. Okay, let's see. So I am saying that if you have two apples, okay, and read this line that only type of fruit matters, not the individual piece. Okay, and type is same, both are apple, so type is same. Now I am saying that if you want to select one apple, then how many ways are there? So you see, this is also apple, this is also apple. There is only one way. There is only one way. Why? Because because the individual piece does not matter, only the type of fruit matters, and both are apple. This is also apple, this is also apple. So if you select this, then if you select this, okay, and if you select this, then they are not different, they are same. Because you just want to select apple. You just want to select apple. If they were different, let's assume if they were different, okay, this is a fresh apple and this is maybe Kashmiri apple, at that time you could have said that okay, there are two ways. But we are saying that they are perfectly identical. Or we can say that it does not matter which piece you select, as long as you are selecting apple. So this is the line, this is the meaning of this line. Only the type of fruit and not the individual piece matters. So the only the type of fruit matters. Okay. So from this category of apple, if you select one apple, then it does not matter which apple you are selecting. Okay, from this set of apples, if you select one apple, then there is only one way. Okay, hopefully you got the meaning of this line, right, Santosh? Did you get the meaning of this line? Yeah, final answer we will see, don't worry about it. Final answer we will see. Now, read the last line. The last line is saying there are at least four pieces of each type of fruit in the bowl. So basically, in this market, you go to this market, and here he is saying that at least at least four apple. So maybe more than four are maybe available. Similarly, at least four oranges are here, and similarly, at least four pears are here. And now you have gone to this market and you want to select four pieces of fruit. You want to select four pieces of fruit. So how many ways you can select four pieces? In how many ways you can select four pieces? So maybe you do not select apple, maybe you do not select orange also, maybe you only select pears. So remember this, what does this means? When I read 00 for this means that you did not select any apple, you did not select any orange, you selected four pears. So how many ways are there to do this task? Sorry, to do this kind of selection. How many ways are there? Can anyone tell me how many ways are there to do this kind of selection? How many ways are there to do this kind of selection? So you went to the market, and now you are neither you are not taking any apple, you are not taking any orange, you just went to the counter where pears are, pears are present, and then you pick four pears. Then how many ways are there to pick four pears? Anyone? Okay, let me tell you. So there is only one way. Why? There is only one way. Why? Because you see, all these pairs are same. Basically, individual piece does not matter. So it is like this. So there is a there is a pool where where pairs are present, pairs are present, pairs are present. There are many pairs. Okay, so there are at least four pairs. He has already said that there are at least four pairs. Okay, now there are so many these pairs are present, and individual piece does not matter. We just want to select four pairs. Then how many ways you can select? You can just pick four pairs. So there is only one way. If they were different, then you could have picked them in more ways. But assume that they are all identical. Assume that they are all identical, completely identical. Okay, because the only thing matters is the type of fruit, not the individual piece. So that means if you have everything is identical, at that time if you want to pick one, then there is one way. If you want to pick two, then there is one way. Just pick two. Okay, just extend your hand and just pick four. So if you want to pick four, then also there is only one way. Did you get this point? Any doubt in this? If anyone has any doubt in this, kindly let me know. Got it, huh? Okay, so so that is basically all these are identical. Basically, you can think like this: all these are identical, all these are identical, or all apples are identical. You can think like this. Okay, so when you think of all the apples as identical, then it does not matter which apple you are picking. Okay, the only thing matters is how many apple you are picking. So if you pick one apple, then that is a different thing. If you pick two apple, then that is a different thing. So basically these two are different thing. But if you pick two apple, and if some other person picks two apple, then they are same thing. Okay, so the only thing matters is how many these fruits you are picking. So this is one way. Now what is another way? Maybe uh, another way could be possible like this. Maybe you do not pick any apple, but maybe you pick one orange, and you pick, then you have to pick three these three pears, right? So if you pick one orange, then you are left with this choice that you have to pick this uh, three peers. So how many ways are there to do this? Can anyone tell me how many ways are there to do this? This kind of selection, how many ways are there? Specifically this kind of selection, yes, right, Gayatri, right. So there is only one way. Why? Because see, you are not picking any apple. Now you are going to the you are taking your basket to this orange counter, and you are picking one orange. Okay, so one orange you can pick only in one way, right? Then you are going to this pairs counter, and then you are picking three. So you see, there is only one way to do this. You can pick one orange and also three pairs. So there is again only one way. So that is actually because all these oranges are identical, all these pears are identical. Because of that, this kind of thing is happening. If they were different, then we would have gotten different answers. Okay, so now you can see this. You can see this explanation here. These are the different ways possible. For example, these are the different ways possible. to solve this problem, he has listed out all the ways possible. Okay, in the first way, what he is doing, he is selecting 4 apples. So if he is selecting 4 apples, then but types are different. Right. See, when I write like this 400, this means that I am picking 4 apples, 0 oranges, 0 pears. Okay, so how many ways are there to do this task? There is only one way. But you are right, types are different. So when I write like this, now this is different from this. When I write like this, then this is different from this, because types are different. So here we were picking 4 apples, here we are picking 4 oranges. So this selection is different from this selection. Okay, and how many ways are there to make this selection? There is only one way. You can just extend your hand and pick 4 apples. Now how many ways are there to do this selection? You can just extend your hand and pick 4 oranges. So again there is one way. Now if you do this, for example, if you do this, then this is a different way. Why? Because here you were purchasing apple, here you were purchasing oranges, here you are purchasing pears. So you see, these three are different ways. These three are different ways. But if I ask you how many ways are there to do this particular selection, 004, how many ways are there to do this particular selection, then there is only one way. This is what we are saying. Did you get it, Santosh? Any doubt? Okay, so now you can see this, actually this solution, you can see there are answer will be 15, and you can see why 15. Actually he has listed out all the possibilities. Okay, but of course you might be thinking that listing out all the possibilities is not a efficient way of solving. Okay, so we will see formula also, but don't worry. But before that, we just want to understand the problem. That's why we have taken this much, because this problem we have to understand. You see how like this is not easy to understand that this particular selection will be only of one way. Okay, so we first want to understand the statement of the problem. After that we would like to solve this problem. Okay, so now we shall let's see. Now this is our formula. So if you were waiting for a like a formula to solve this question, then this is our formula. What this formula is saying, we will also prove it, don't worry, we will also prove this formula. So this formula is saying that from a set with n elements, when repetition is allowed, okay, there are these many r combinations. Okay, so we will take this formula, don't worry. Before that, so this is the proof of that formula. So we will let's try to prove it. Let's try to prove it. So to prove this, we will do like this. So what we are saying, let's assume that there are n identical elements. Let's assume that there are how many? Sorry, right. So you have n identical elements. Let's assume you have n identical elements. So everyone is same. So basically you can think like this, a, and so on. So how many elements are there? N elements are there. Okay, wait a minute. Allowed. So he is saying that you want to select r r elements from a set of n elements when repetition is allowed. He's saying that. Okay, so the statement is different. Okay, so the statement is different. Statement is that you have again you have n element set. So there are n elements here, 1 2 3 and so on. You have n elements. Now you want to select, let's assume you want to select 2 elements, but repetition is allowed. You want to select 2 elements, but repetition is allowed. Then how many ways are there to select 2 elements? Before that, let's just solve. When repetition is not allowed, then what is the answer? Then it is simple, nc2, right? then it is simple. When repetition is not allowed, at that time there are only NC2 ways to select two elements, right? But when repetition is allowed, then what will happen? So if repetition is allowed, then you can select these two times, right? Because repetition is allowed, so you can do like this. So this is one way. Okay, similarly you could have done like this 1 comma 1. Okay, or you could have done like this 1 comma 2. So you see, when repetition is allowed, at that time how many ways are there? That is what we are interested in. Okay, when repetition is allowed. So if repetition is allowed, then you can repeat this element. You wanted to select two elements. Okay, but if repetition is allowed, at that time you can even this kind, you can make even this kind of selection, you can even make this kind of selection, or this kind of selection, and so on. Okay, now how we can solve this question? So we want how many elements we want? We want r elements. How many elements we want? We want r elements. And uh, so let's assume these are the r elements. Let me just put them like this. Okay, so these are the r elements. Now, so we want r elements. Now, so wait a minute. So what I'm saying is r elements. Let me just think of like how we can prove it. So if we have n elements, then we can make so we are choosing 0 from here. N elements, repetition is allowed. We are not choosing anything from here. We can put this to, so if we put this, then that means each R combination of a set with repetition allowed can be represented with by a list of n minus 1 bars, star star star. So okay, let me do this. I'll take this question in the next class. Somewhere like I'm confused. So let me take this part in the next class. Okay, I will repeat this part in the next class. So let's move to the next part right now, because actually I do not just want to give you the formula. Okay, I could have just given you the this statement, like this statement, this formula. Okay, because in many coaching centers they only provide the theorems and these kind of thing, but I also want to prove this thing to you. Okay, I also want to prove this thing to you. So this is the proof, actually this is the proof. So in the next class I will repeat I will tell you this proof. Okay, so for this class, just let's just take this theorem for granted. Okay, so the only thing that will be missing is how we can prove it. Okay, so I will prove it in the next class. But for now we will just take this thing for granted, okay, that this is the formula. Whenever you have a set of n elements, and if you want to make a r combination, then these are the number of ways: n plus r minus 1 cr. So basically this is the n plus r minus 1 cr. This is the formula for making r combination when repetition is allowed at that time. So for now, let's assume that this formula is correct. In the next class we will also prove it. Okay, so for now let's move on. I will give the proof in the next class. So before that, if you have already know, if you already know this formula, let's assume if you already know this formula, that n plus r minus 1 cr. So this is our formula whenever whenever we want to make a r combination from a set of n elements. Remember this formula for once. For today's class, just remember, just by heart this formula. In tomorrow's class we will prove it. So for now, try to solve this question. Try to solve this question. You have the formula, so this is the formula I have written. Now try to solve this question. Right. So in this question, what he is saying that you have four different kinds of cookies. So this is cookie one, this is cookie two, this is cookie three. Okay. So these are four different kind of cookies. But let's assume this is cookie number one. So all the cookies in this set are identical. Similarly, all the cookies in this set are identical. Similarly, all the cookies in this set are identical, and all the cookies in this set are identical. But these are the four different types of cookies. So a cookie from here and a cookie from here are different, but a cookie from here and a cookie from here are same. So this is the meaning of these lines. Okay, now he is saying, suppose we have this cookie shop, and has these four different kinds of cookies. Now how many different ways are there to you can choose six cookies. So you want to make so six combination you want to make. So the value of r here is 6. Okay, and the value of n here is 4. So this is our idea basically. uh, so you whenever you solve these type of questions, you can also write them like this: x1 plus x2 plus x3 plus x4 is equal to 6. Basically this is what we want. Where what is x1? X1 is a number of first type of cookies. What is x2? X2 is number of second type of cookies. X3 is number of third type of cookies, and x4 is number of fourth type of cookies, and the total must be 6. Okay, so let's assume that you picked six here. So basically you picked six first type of cookies. Then the only possibility is that you have to pick 0 here, 0 here, 0 here. Okay, so you can see this is one way. This is one way. Similarly, if you pick 5 here, 1 here, 0 here, 0 here, this is another way. Similarly, if you pick 5 here, 0 here, 1 here, 0 here, so this is another way. So basically we want to find how many number of ways are possible, how many number of ways are possible. Okay, such that we just want this summation to make 6. So this summation, this complete summation must make 6. Okay, and each of these individual items can be minimum this 0 and maximum 6, right? Can be minimum 0 and maximum 6. Why? Because you can see in this case when you picked a 6 here, 0 here, 0 here, 0 here, so you can see these three items are 0 and this item is 6. Okay, so you can see each of these individual items can be minimum 0 and can be maximum 6. Okay, so this is the kind of problem that we are looking at. Remember, you have already solved this question, that I know, but I am saying that whenever actually such kind of problems are given to you, at that time you can write that problem in this form. Okay, so in which form we have written it in x1 plus x2 plus x3 plus x4 form, where x1 means how many number of type 1 cookies you have picked. This x2 means how many number of type 2 cookies you have picked, and so on. So basically we want to make this summation equal to 6, right? We want to make this summation equal to 6. And also we have this condition that each of these elements can go from 0 to 6. So you can see, because we can minimum take 0, uh, we can take like this type 2 cookie, maybe we are not interested, and we can pick 0 from here, we can pick 0 from here, we can pick 0 from here. But now to make the summation 6, we have to pick 6 from here. So this is the actually formulation of this problem. Why I am making this formulation, you will see in the next few examples. Because this kind of problem also comes in many different contexts in combinators. You will see this thing. So whenever we have this kind of problem, Okay, so this is the solution you can refer. But what I'm saying this thing, that whenever we have this kind of problem, x1 plus and so on, x uh, so xr is equal to n. Okay, it does not matter, you can put n here, r here, that does not matter. Basically whenever we have this kind of problem, okay, at that time, so whenever we have this x1 plus x2 plus xr n, so at that time, if also additional condition that each xi goes from 0 to n, this is the additional condition. So how many ways are there to make this kind of ways? Okay, so basically we want to make the summation equal to n, that is the first condition. And the second condition is that each individual xi can go from 0 to n. So how many ways are there? The number of ways are xn plus r minus 1 c r. So this is the number of ways. So this is what you have done in our this example, x1 plus x2 plus x3 plus x4 is equal to 6. This is what you have done. So 6 plus wait uh, so okay, this is r, actually this is r, because we want to make r combination. So this is r and this is n. We want to make r combination, right? We want to make r combination, so the summation must be equal to r. The summation must be equal to r, and this is n. So this is the formula, n plus r minus 1 c r. So similarly here you can see this is r. So our formula will be, this is n, so 5 plus 4 plus 6 minus 1 c cr, and what is r is 6. So we will get 9c6. So this will be our answer. Okay, so remember, actually by mistake I wrote n here. So because we are making r combination, what do we mean by r combination? We are interested in picking, selecting r things. Okay, so that's why actually the summation must be equal to r. Okay, and this n basically tells us that different type of things, how many different type of things we have. So we have n different type of things. Like in the apple, orange and pears example, n was 3 because there were 3 different type of things. Okay, in our this example, this cookie example, there are 4 different kind of cookies. So n is equal to 4. Okay, and r is equal to how many r combinations we want to make. So in this cookies example, we want to make we want to select 6 cookies. So here r is equal to 6. Okay, so this is the this is the formula, and this is the type of question that we can solve on this problem. We will take few more examples. Try to solve it. Try to solve it. Remember the template. Okay, always remember the template. So basically I have already discussed that the template is like this: x1 plus x2. Whenever you have this kind of template, xn is equal to r. Whenever you have this kind of template, that you need to make the summation equal to r. You need to make the summation equal to r. Also you have this condition, xi is less than or equal to 0, or maximum xi can go from 0 to r. Okay, 0 to r. So at that time, and let's assume that these all are identical. What do I mean by identical? So basically if I put 2 here, okay, then it does not matter what these two are. So basically these two are identical. The only thing matters is how many number of way. For example, if I put 2 here, then that is different from this 3, but this 2 is not different from this 2. That is what I want to say. Okay, so this is a template. This is a template. Remember this template, and the proof of this template we will give in the next class. But remember this template, because this is a very very important template. So let me just again repeat that in this template, all these xi's can go from 0 to r, where r is this value. Basically we want the summation to be r, and this n indicates how many different type of things we have. How many different type of things we have, this is indicated by this n. Okay, and now if you want to find the number of ways, if you want to find number of ways in which you can make the summation equal to r, then that is equal to n plus r minus 1 c r. So this is the formula. So this is the template. Okay, Now, in any problem, in any kind of problem, if you can somehow, if you find out that actually your problem has this template, your problem has this template, then you can solve this that problem using this formula. So try this question. Try this question. Okay, let let others also try. Just try once. We will, don't worry, this template is actually very important template, and that's why we are going to see many problems on this here also, and in the further part of our slides also we have this, we will be using this template. So this is from gate point of view also, this template is important. I have already discussed this template that whenever you have this kind of template, x1 plus x2 plus and so on xn is equal to r, where the condition is that each xi must be from 0 to r. If this is the condition, if this template is met, then your formula will be then your formula will be n plus r minus 1 c r. So let's try to solve it. He's saying that how many solutions this equation has, how many solutions this equation has. So we have this equation, x1 plus x2 plus x3 equal to 11. So this is our equation, this is our equation, and he is saying that where each these xi are non-negative integer. What do we mean by non-negative integer? So each xi, x1 or x2 or x3, each I xi should be at least 0. Non-negative integer, non-negative integer means it should be at least 0, and it can go to because if it is possible to be 0, for example, if this becomes 0, this becomes 0, then this will become 11, right? Because we want the summation to be equal to 11. So we can see that xi is going from 0 to 11, because this is already given that each xi is non-negative integer. So each xi has to go from 0 to 11. Why? Because it cannot go more than 11. Because let's assume that this x1 goes to 12. Let's assume that x1 becomes 12. Then we can never make this summation equal to 11, because each xi is a non-negative integer. So you can see again the same template we have encountered, where each xi is from 0 to r, and here r is this, here r is this, here n is this. Okay, this n means, okay, how many different type of things we have. So you can see these are the different type of things. And also remember that it does not matter, for example, actually, if you pick 2 here, let's assume if you pick 2 here, then 2 plus 2, and this has to be 7, right? This has to be 7. Now if you see, if you put these two here, let's assume we interchange these two. So if you put these two here and these two here, then this is not a different way. You can see these two are same, these two are same. So you can see the only thing matters is how many different xi we have. It does not matter, for this is same thing as oranges or apple. For example, when we have a set of apple, at that time if you want to pick 4 apple, then it does not matter which 4 apple you are picking, because there is only one way. okay, because all the apples are identical. Similarly here, here what we are saying that if you for example, if one solution is 2 plus 2 plus say 1, then then there is only one kind of this solution. Then if I ask you how many this type of solutions are there, then there is only one solution. But remember, if I interchange this like this, 272, then this is a different solution, then this is a different solution. Why? Because you can see here the numbers have changed. Here the numbers have changed. Here it was 2 and here it was 7. So the only thing matters to us is number, how many number, how much number we are giving to this xi. Okay, so if we are giving it 2, then that is a different scenario, and if we are giving it 7, then that is a different scenario. But let's assume you give it one time you give it 2, and the next time you give it 2, then they are same scenario, then they are same scenario, right? So that is what I want to say, that if you have this solution 2 plus 2 plus this is a particular solution. This particular solution has only one way. This particular solution has only one way, because okay, so hopefully you are understanding this template actually. So there are many conditions here. The first condition is that summation must be equal to r. The second condition is that each xi must go from 0 to r. So this must be r here, and this must go from 0 to r. Okay, so this is second condition. And the third condition is if you have some particular solution of this equation. If you have some particular solution of this equation, so this 227, this is a particular solution of this equation, then this kind of solution, how many how many solutions of this kind are possible, this particular solution are possible, that is only one. Did you get this point of particular solution? If you have, if I tell you, for example here, if I tell you that you have to select 4 apples, then there is only one way. But if I tell you how many ways are there to select either 4 apple or 5 apple, then there are 2 ways. Okay, because selecting 4 apples is one way, selecting 5 apples is another way. Okay, so that is what is happening here. Every particular solution has only one way. For example here, if you select only 4 apples, then that is a particular solution. So selecting 4 apples, that is a particular solution, that has only one way, that has only one way. This is what I want to say, this is the template. Okay, so now once we have established that, okay, this question also satisfies this, basically this question also satisfies our template. So now we can just directly write the answer, and the answer will be n. N is 3 here, plus r is 11 here, minus 1, n plus r minus 1 c r, and r is equal to 11. So this is our answer. So this will be 13c11. Okay, or you can also write it like 13c2. This is also correct. Why? Because ncr is equal to nc n minus r. Okay, so this is the solution. You can refer to this solution after that. Okay, so 13c 11 is the solution. Hopefully you are comfortable with this template. So we will discuss the proof of this template in the next class, but you should practice this template now a lot, because this is a very important thing. So these are just the simple things that we have already discussed. For example, if repetition is not allowed, then how many r permutations are possible? This is npr. If repetition is not allowed, then how many r combination are possible? That is ncr. If repetition are allowed, then how many r permutation are possible? That is n power r. This also we have seen. If repetition are allowed, how many R combinations are possible? That is equal to n plus r minus 1 CR. So this is also we have seen. But remember, all these first three things were easy. All these first three things were easy. But this fourth thing actually this is more important, and this is not that easy to understand. You have to once I give the proof in the next class, okay, then it will become easier. But that proof will not help you in exam, because in exam you are not going to prove anything. Okay, the proofs are just for our our understanding. Okay, but you should understand this template template, because in question they are, in exam they are going to ask you question on this template. Okay, and you will read the problem, and as soon as you read the problem, okay, if you find that okay, this problem has the same template as this problem, then you can easily just apply this formula and get the answer. So the only thing is identifying this template, and I have already discussed. Okay, what is this template? This template has simply n distinct type of elements. So this n basically represents how many type of elements we how many types we have. So okay, this r tells us how many elements we have to pick, how many elements we have to pick. Okay, so now basically the summation must be equal to r, and each individual these xi can go from 0 to r, because you can minimum you can pick 0 and maximum you can pick r, and you want the summation to be equal to r. And remember that each particular solution has only one way. Each particular solution has only one way. So if this template is met, if this template is met, then you can just directly apply this formula and you can solve this type of questions. Okay, so today time is over. In tomorrow's lecture we will finish combinatorics. We will take more questions in this template, because this is a very important template. So in my slides I will add five more questions in my slides. We will solve five more questions on this template tomorrow. So okay, so see you in the next see you tomorrow. This combinatorics will be over. Don't worry if you did not understand anything. In tomorrow's lecture everything I will cover everything on this template. We will solve five questions. Once we solve five questions, then this template and every type of questions will on this template will be over. So you won't have any problem, don't worry. So I'm pausing the recording. Thank you, Santosh. Actually, it's a good thing that you told now, because not much has been recorded, not much has been discussed so far. Most of the things we have discussed so far were already discussed in the last lecture. So let me just quickly one time and tell what has been what we are teaching. So we are teaching combinations, because we have already discussed about permutations in the last lecture. Now we are discussing combinations, and in combinations what we are saying that if you have a set A, and if you, let's assume that you want to make subsets of this set. If this is the set, then you want to make subsets of this set. So S is a subset of set A, and let's assume you want to make subsets which are of size 3. So you are interested in only in subsets of size 3. Then we are saying that this problem is different from the permutation problem, because in permutation problem what we were doing, first we were picking R elements, first we were choosing R elements, then we were arranging those R elements. Okay, but here what is happening, first we will pick R elements. Let's assume here we are picking only 3 elements, because we are interested in subsets of size 3. So here we are picking 3 elements, and then once we pick 3 elements, then you can see ordering does not matter, because with 3 elements, okay, let's assume you have picked 1 comma 2 comma 3. With these 3 elements there is only one possible set you can make. So this is the only possibility, because set is a ordered collection. So in set order does not matter. So this problem is different from the permutation problem. In this problem we do not have to arrange. In this problem we only have to select. So the only work we have here is selecting 3 elements from this set. We are not going to arrange it, or you can say we are not going to permute this thing. That what we are saying, basically we are saying, basically what I'm saying is permutation. You can think of permutation as, or permutation is similar to arrangements. or arrangements is similar to ordering. So you can see in all these things, order matters. Permutation, arrangement, or ordering, in all these things, order matters. And combination, what do we have? What do we mean by combination? Combination means selection. Okay, selection. Or here you can see, order does not matter. The only thing matters is what are the elements that you have picked. Now we will see how many combinations are possible. Now our task is to see how many combinations are possible. So let's see this, how many combinations are possible. Remember, in permutation problem, what were we doing? In permutation problem, what were we doing? So we had some n elements. You can see in permutation problem we had some n elements, and we our what we were doing, we were picking r elements. First we were picking r elements, and then we were arranging them. So this is our first, it we were doing this, picking r elements from this set of n elements, and then we were arranging them, and then we were arranging those r elements. So you can see the final answer was npr. We have already discussed this in previous lecture, because to fill this position we have n choices, to fill this position we have n minus 1 choices, and so on. To fill this position we have n minus r plus 1 n minus r plus 1 choices. So you see, this is what we saw in last lecture. So these are the number of, this npr is the number of arrangements possible with r elements out of n elements. So now here one thing that you can see, what is that thing? That actually this npr basically is a sequence of two tasks. This npr is basically sequence of two tasks. The first task is, first you pick r elements. First you pick r elements. Okay, so first you pick r elements. So let's pick our elements. Let's assume that this is some formula that that picks our elements. Okay, now after that, after picking our elements, we have to also arrange those r elements, right? We have to arrange those r elements, and we already know how many ways are there to arrange r elements. That is r factorial. Did you understand? So let me just quickly let me give you an overview. We have already seen in last lecture that if you have n elements, and from those n elements, if you want to arrange r elements, then this is the formula. This we have already discussed. Okay, now I am saying that this task, which task? So, this task, that arranging r elements from n elements, arranging r elements from n elements, this task can be divided into a sequence of two tasks. What is that sequence? The first is, first you pick r elements. First you pick r elements, then you arrange those r elements. So okay, first you pick r elements and you arrange those r elements. So you can see here, we are multiplying. Why? Because you can see there is a and there. Okay, so we are going to use the product rule. So we do not know how many ways are there to do this task. What is this task? Yes, we are going there. We are going there. NCR, we are going there. So I am saying that we, let's assume that so far we do not know how many ways are there to do this task, and this task is picking our elements. So let's assume that there is some formula, and this formula is somehow picking our elements. So this formula is actually giving us